Hello, everybody. Welcome to seventh grade, Unit 1. 7.1, we're talking about scale drawings. More importantly, scale copies. This is going to be the start of our journey through equivalent ratios and proportional relationships. Our vocabulary: equivalent ratios, proportional relationships, scaled copies, scale factor, scale, and scale drawings. So we're going to get started with our first lesson. It's called scaling machines. Now, the way this is going to work, we are going to start off with what Desmos talks about, which is the first lesson. What are scale copies? We're going to start off with that, but we're also going to go into some board work, and I'm going to show you how things look whenever we are actually start working on the board. So you work with your on your own capacity of drawing. So let's get started. So the very first one we're going to go into, we'll start off with our warm-up. And so the warm-up says, click and draw a few points or drag a few points to create your shape. So we're going to do this. And when you have your computer and you're able to do things, you can easily do this. Okay. All we're doing is just creating a shape. That's all. Nothing important, nothing really fancy or hard. So let's not get into our head. So let's go to the next one. So the next slide shows us what we drew. And what we're going to do is print it. And guess what? Looks just like that one. See that? This is the same as that. This line is the same as that line. Okay? So things that stay the same. Everything stayed the same. Nothing changed. Okay? And it says, no matter what zoom level, what stays the same? Well, the shape stays the same. The angle stayed the same. Okay? Let's move on. So let's print again. It says the printer's broken this time. Oh, that doesn't look like this, does it? Nope. This one has a curved point here when this one does not. It's curved over here when this is all straight. So that's how we describe this broken. Okay, moving on. This one's also broken. So everything is what? Looks thinner, doesn't it? It's flatter. All right, the angles are sharper here. Right. All right, let's move on. Now, printouts 1, 2 are scaled copies. Why? Because it looks just like the original. See that? They look just like the original. But 3 and 4 are not because they don't look like the original. The angles are different. The edges are different. Everything is different. Okay, move on. So now I want you to sort the cards based on whether they show scale copies. So let's see. Does this show scale copy? This is flatter, sharper. See that? So this is considered not a scale copy. You're right. What about this one? Same thing, only smaller version. So this is considered a scale copy, right? What about this one? This is very narrow. This is very wide. This is not a scale copy. Good. Let's see. Let's move on. This opening is really wide. This opening is narrow. So this would be considered not a scale copy. You got it. And this one, you guessed it, it is a scale copy. So we put it over the scale copy. So we'll move this over here and move this over here. You can see how the scale copies look. They look just about identical, only the version is smaller. Whereas the not scale copies, they have the same colors, but their angles are different, their shapes a little different. Okay, so That's one thing you got to look at when you look at scale copies. Let's make this bigger. There we go. All right, let's move on. All right, so we talk about scale copies. We also talk about equivalent ratios and proportional side lengths. So that means the side lengths are proportional to each other. And what does that mean? Well, that means this. If I take 4 and 6, and let's say I take that, we're going to use our calculator this time. Okay, so if I take 4 and then I divide it by 6, I know that's going to be points to the point 0.6. All right. Now, if I go in, let's say I go in and I do the same thing. Remember, I compared 4 and 6 first. Now I'm going to compare 2 and 3. So let's do that. 2, and then we're going to divide it by 3. Okay, and we get what? We get the exact same answer. Notice that we get the exact same answer. So when we compare sides, we're comparing the side lengths here to here and here to here. Now, we can flip this around and we can do it the opposite way, and it still works. How do I know? Watch. If I say 6 divided by 4 this time, I get 1.5. And then if I take 3 and divide it by 2, guess what? 1.5 also. So think about that. So when I compare sides, I have to compare the same side to the same side if I want to make sure I have the right equivalent ratios. They have to be compared to each other, the same sides. Okay, watch this. If I make this bigger, okay, notice what it says. 6/4 is not equal to 10/7. So let's see what will make it equivalent. Will that do it? Huh. See if that will do it. Oh, look at there. 6/4 is equivalent to 12/8. Okay. How do I know? Well, let's go and check it out. So before we did 3 over 2, 6 over 4. So we're going to do 12 over 8. And then we get, guess what? There it is, 1.5. So this is correct. They are proportional relationships. They are equivalent ratios. Okay. All right. I'm hoping you're understanding that the equivalent ratios is how we figure out if this is a scale copy of this. So scale copies mean that the ratios between the sides are equivalent or equal proportions. All right, let's move on. All right, I'm hoping this sinks in. If not, rewind the video so you can actually hear what I'm doing all over again until you catch it. So how does each machine work? Which machine makes scale copies? So say draw something. So we're going to draw this. Boom. Now, machine 1, well, it looks the same. It's just upside down, right? Let's see what machine 2 did. Oh, it made it elongated. Does that scale copy? No. This one. Oh, it made it bigger. And scale, see machine 4. And it doubled it. Okay. So which machines made scale copies? So, if I'm not mistaken, these are scale copies. So 4, let's see what 2 did. 2 elongated it. What did 3 do? 3 just made it bigger. So could this be considered a scale copy? Yep. Can that be considered a scale copy? Yep. Can that be considered can that be considered scale copies? Yes. So our machines 1, 3, and 4 are scale copies machines. All right, moving on. All right, so in general, how can we tell whether or not the figure is a scale copy of the other figure? So you can explain that. The size is different, but the shapes and angles are proportional to each other. They have the same proportions. So if I divided one side by the other side here, and I did the same thing to these two sides, I would get the same answer when I divided it. That's how you know it's a scaled copy. And let's go to number 10 for our cool down. Click one shape that is not a scale copy of figure A. Where's figure A? Figure A is right there. Okay, so which one's not a scale copy? Let's see. I bet this one's not a scale copy. I bet this one's not a scale copy, right? Well, let's check. Think about it. If I go here, I see this is 3, and that's 2, right? So let's go on the calculator. Yeah, we're going to figure this out on our own. So if I did the equivalent here of 2 and 3, I get 2 divided by 3. That's A. So we need everything to be 0.6. We're going to divide this by that. Okay, so here's 3 divided by 3. 3 divided by 3 is 1. So that is definitely not a scale copy. Okay, what about this one here? This is going to be 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. Let's put that in there. 4 divided by 6. Up, that one's a scale copy. That one won't count. What about F? That's going to be 1, 2, 3, 4, 5. That's 2. So 2 divided by 5. Whoops, something messed up. Hold on. 2 divided by 5. It's 0.4, so it doesn't work. So this one's not a scale copy either. Okay. Now this one right here could be a scale copy. The only problem is, look how fat it is. Just by looking at that, you can see that's not a scale copy. So yeah, this one right here is 1.5 by 1. That's basically, or 1 by 1.5. Let's put that in there. Let's do it. 1 divided by 1.5. And guess what? It works. So our scale copies is A, E, and C. All right. And so B, F, and D are not scale copies. And we know that because we compared them or we looked at them. All right. Okay, so good job for now. Now, let's go ahead and look at some things real quick. Okay. All right. So when we compare scale copies, as you saw, you have something that looks like this, and then something that looks like this. All right. Same basic shape, only bigger. So if I put numbers to this, let's say I put I put 3 here and 4 there, and I put 6 here and 8 there. All right, so now we know that our equivalent ratios have to be between these two. And how do we figure that out? Easy. We take 4 divided by 3 and 8 divided by 6. Or we can easily do 3 divided by 4 or 6 divided by 8. Either way, you're going to come up with the same answer. You're going to come up with 0.75 here, 0.75 here, or you come up with 1 1/3 here and 1 1/3 there. Okay. So when we're looking at equivalent ratios, that's how we compare them, right? The other thing we got to think about is if this is 3 and that's 6, this is 4 and that's 8, how did I get from the small one to the big one? Yes, you multiply it by 2. So that means 2. So 3 times 2 equals 6, and 4 times 2 equals 8. So notice that the common factor that we multiplied by was what? 2. And that's what we're going to get into next. It's called scale factors. Okay? So when we get back to this next time, that's what we're going to talk about, scale factors. I hope this helps. Talk to you later.